Imagine if we could detect signs of super-advanced alien civilizations in our galaxy. Exciting, right? Recent research suggests that at least 7 stars in our Milky Way might be surrounded by Dyson spheres, hypothetical structures built by advanced civilizations to harness energy from their stars. In this video, we will explore the new findings, understand what Dyson spheres are, and delve into the significance of this discovery. Recent research findings. A new project known as Project Hephaestos brought together a team of researchers from Sweden, India, the UK, and the USA. Their goal was to analyze vast amounts of astronomical data to uncover signs of advanced civilizations. They focused on technosignatures, which are indicators of technology used by intelligent beings. One such technosignature is unusual infrared emissions that might suggest the presence of a Dyson sphere. They used data from 3 major astronomical surveys, Gaia, 2MASS, and WISE. These surveys provided a wealth of information about stars across the galaxy, including optical and infrared observations. By combining data, researchers aimed to identify stars exhibiting infrared excess emissions that could not be explained by natural phenomena. They developed a specialized data pipeline to sort out the data and filter false positives. They began by examining around 5 million sources. After filtering and analysis, they identified 7 stars with infrared excess emissions consistent with the presence of Dyson spheres. These stars are all M-type or red dwarf stars known for their relatively low temperatures and long lifespans. Their infrared excess emissions are intriguing because red dwarfs typically do not have the warm debris disks that could naturally explain such emissions. The detection of these 7 candidates is significant for several reasons. First, it demonstrates the effectiveness of the data pipeline developed by the researchers. This pipeline successfully filtered out natural sources of infrared excess, such as circumstellar dust rings, nebulae, and background galaxies. By using this method, they were able to narrow down their search to a few promising candidates. Second, if these infrared excess emissions are indeed due to Dyson spheres, it would suggest that at least 7 advanced civilizations have developed the technological prowess to build such structures. To confirm the presence of these potential Dyson spheres, researchers suggest follow-up optical spectroscopy, which could help determine whether the infrared excess emissions are due to natural phenomena or advanced technological structures. This additional analysis will be crucial in verifying the true nature of these sources and understanding the implications of this discovery. Understanding Dyson spheres. To appreciate the significance of this discovery, we need to understand what a Dyson sphere is and its theoretical formation. The concept, first proposed by physicist Freeman Dyson in 1960, suggests that a highly advanced civilization might build a massive structure around its star to capture and utilize its energy output. His idea was inspired by the realization that as civilizations grow, their energy needs increase exponentially. To sustain this growth, they would need to harness their star's energy more efficiently. A Dyson sphere can take various forms. The most extreme version is a solid shell that encapsulates the star, capturing all of its energy output. However, constructing such a structure would be incredibly challenging due to immense engineering requirements and the need for strong materials. Therefore, other forms have been proposed, such as a swarm of solar-collecting satellites or a ring of solar panels orbiting the star. These alternatives, while still advanced, are considered more feasible than a solid shell. The concept of a Dyson sphere falls under the Kardashev scale, which is a method of measuring a civilization's level of technological advancement based on its energy consumption. A Type 1 civilization, also known as a planetary civilization, can harness all the energy available on its home planet. Its home planet. A Type 2 civilization, or stellar civilization, can harness the energy of its entire star, which would be achieved through the construction of a Dyson sphere. A Type 3 civilization, or galactic civilization, can harness the energy of an entire galaxy. Will we ever be able to build a Dyson sphere? Achieving this would require technological prowess far beyond our current capabilities. It involves not only capturing solar energy but also overcoming immense engineering challenges related to material strength, stability, and maintenance. The civilization undertaking such a project would need advanced technologies for construction and upkeep as well as efficient methods for converting and storing the captured energy. Despite being theoretical, the concept has captured the imagination of scientists and science fiction writers alike. It represents the pinnacle of technological advancement and the potential for near-limitless energy. Detecting a Dyson sphere would answer one of humanity's most profound questions: are we alone in the universe? So searching for these spheres is not just a quest for scientific knowledge but also a journey to understand our place in the cosmos. Research implications and historical context. Early searches for these megastructures were limited by the technology of the time. In the decades following Dyson's proposal, astronomers primarily used radio telescopes to search for techno-signatures, such as unusual radio signals that might indicate advanced civilizations. However, these searches did not yield definitive evidence of Dyson spheres or other techno-signatures. One notable early attempt was in the 1980s. Although it detected many sources of infrared radiation, none could be conclusively identified as Dyson spheres. These findings implied that if Dyson spheres existed, they were either very rare or difficult to distinguish from natural sources of infrared radiation. In the 1990s and 2000s, advances in infrared astronomy and data analysis techniques allowed for more sophisticated searches. As we mentioned, projects like the 2-micron All-Sky Survey, 2MASS, and the Wide Field Infrared Survey Explorer, WISE, provided comprehensive infrared data on millions of stars. As with the early attempt, no definitive evidence of Dyson spheres was found. The recent research by Project Hephaestos builds on these earlier efforts by combining data from multiple astronomical surveys and using advanced data analysis techniques. The second phase applied this method to a larger data set, resulting in the identification of 7 promising candidates. In contrast to the early research, Project Hephaestos leveraged modern astronomical surveys that allowed researchers to identify potential Dyson spheres with greater precision and confidence. Confirming the existence of Dyson spheres would require comprehensive data and rigorous analysis to rule out natural explanations. The scientific community must also replicate the findings using different methods and instruments to ensure their validity. While this process may take time, it is essential for establishing the credibility of the discovery and advancing our understanding of advanced extraterrestrial civilizations. In conclusion, the history of searching for Dyson spheres reveals the evolution of scientific inquiry and the continuous pursuit of knowledge about the universe. The recent research by Project Hephaestos represents a significant milestone in this journey, demonstrating the potential for modern technology and collaboration to uncover signs of advanced civilizations. Thank you for watching. As we continue to explore these candidates and conduct further analysis, we may be on the verge of a groundbreaking discovery that could revolutionize our understanding of the universe and our place in it. Stay tuned for more exciting updates.